Safe RLHF, Safe Reinforcement Learning from Human Feedback. With the development of large language models, LLMs, striking a balance between the performance and safety of AI systems has never been more critical. However, the inherent tension between the objectives of helpfulness and harmlessness presents a significant challenge during LLM training. To address this issue, we propose Safe Reinforcement Learning from Human Feedback, SAFE RLHF, a novel algorithm for human value alignment. SAFE RLHF explicitly decouples human preferences regarding helpfulness and harmlessness, effectively avoiding the crowd workers' confusion about the tension and allowing us to train separate reward and cost models. We formalize the safety concern of LLMs as an optimization task of maximizing the reward function while satisfying specified cost constraints. Leveraging the Lagrangian method to solve this constrained problem, SAFE RLHF dynamically adjusts the balance between the two objectives during fine-tuning. Through a 3-round fine-tuning using SAFE RLHF, we demonstrate a superior ability to mitigate harmful responses while enhancing model performance compared to existing value-aligned algorithms. Experimentally, we fine-tuned the Alpaca 7B using SAFE RLHF and aligned it with collected human preferences, significantly improving its helpfulness and harmlessness according to human evaluations. Loop Copilot, conducting AI ensembles for music generation and iterative editing. Creating music is iterative, requiring varied methods at each stage. However, existing AI music systems fall short in orchestrating multiple subsystems for diverse needs. To address this gap, we introduce Loop Copilot, a novel system that enables users to generate and iteratively refine music through an interactive multi-round dialogue interface. The system uses a large language model to interpret user intentions and select appropriate AI models for task execution. Each back-end model is specialized for a specific task, and their outputs are aggregated to meet the user's requirements. To ensure musical coherence, essential attributes are maintained in a centralized table. We evaluate the effectiveness of the proposed system through semi-structured interviews and questionnaires, highlighting its utility not only in facilitating music creation, but also its potential for broader applications. Eureka, human-level reward design via coding large language models. To make the text readable for a text-to-speech system, the following pre-processing steps can be applied. Large language models, LLMs, have excelled as high-level semantic planners for sequential decision-making tasks. However, harnessing them to learn complex low-level manipulation tasks, such as dexterous pen spinning, remains an open problem. We bridge this fundamental gap and present Eureka, a human-level reward design algorithm powered by LLMs. Eureka exploits the remarkable zero-shot generation, code writing, and in-context improvement capabilities of state-of-the-art LLMs, such as GPT-4, to perform evolutionary optimization over reward code. The resulting rewards can then be used to acquire complex skills via reinforcement learning. Without any task-specific prompting or predefined reward templates, Eureka generates reward functions that outperform expert human-engineered rewards. In a diverse suite of 29 open-source RL environments that include 10 distinct robot morphologies, Eureka outperforms human experts on 83% of the tasks, leading to an average normalized improvement of 52%. The generality of Eureka also enables a new gradient-free in-context learning approach to reinforcement learning from human feedback, RLHF, readily incorporating human inputs to improve the quality and the safety of the generated rewards without model updating. Finally, using Eureka rewards in a curriculum learning setting, we demonstrate for the first time a simulated shadow hand capable of performing pen-spinning tricks, adeptly manipulating a pen in circles at rapid speed. AgentTuning, enabling generalized agent abilities for LLMs. Open large language models, LLMs, with great performance in various tasks, have significantly advanced the development of LLMs. However, they are far inferior to commercial models such as ChatGPT and GPT-4 when acting as agents to tackle complex tasks in the real world. These agent tasks employ LLMs as the central controller responsible for planning, memorization, and tool utilization, necessitating both fine-grained prompting methods and robust LLMs to achieve satisfactory performance. Though many prompting methods have been proposed to complete particular agent tasks, there is a lack of research focusing on improving the agent capabilities of LLMs themselves without compromising their general abilities. In this work, we present AgentTuning, a simple and general method to enhance the agent abilities of LLMs while maintaining their general LLM capabilities. We construct AgentInstruct, a lightweight instruction tuning dataset containing high-quality interaction trajectories. We employ a hybrid instruction tuning strategy by combining AgentInstruct with open-source instructions from general domains. Agent tuning is used to instruction tune the Llama 2 series, resulting in AgentLM. Our evaluations show that agent tuning enables LLMs' agent capabilities without compromising general abilities. The AgentLM 70B is comparable to GPT-3, 5 Turbo on unseen agent tasks, demonstrating generalized agent capabilities. We open-source the AgentInstruct and AgentLM 7B, 13B, and 70B models at the project's website, serving open and powerful alternatives to commercial LLMs for agent tasks. AutoMix, automatically mixing language models. Large language models, LLMs, are now available in various sizes and configurations from cloud API providers. While this diversity offers a broad spectrum of choices, effectively leveraging the options to optimize computational cost and performance remains challenging. In this work, we present AutoMix, an approach that strategically routes queries to larger LMs based on the approximate correctness of outputs from a smaller LM. Central to AutoMix is a few-shot self-verification mechanism, which estimates the reliability of its own outputs without requiring training. Given that verifications can be noisy, we employ a meta-verifier in AutoMix to refine the accuracy of these assessments. Our experiments using Llama 213/70B on 5 context-grounded reasoning datasets demonstrate that AutoMix surpasses established baselines, improving the incremental benefit per cost by up to 89%. Our code and data are available at the project's website. 3. DGPT, Procedural 3D Modeling with Large Language Models. In the pursuit of efficient automated content creation, procedural generation, leveraging modifiable parameters and rule-based systems, emerges as a promising approach. Nonetheless, it could be a demanding endeavor, given its intricate nature necessitating a deep understanding of rules, algorithms, and parameters. To reduce workload, we introduce 3DGPT, a framework utilizing large language models, LLMs, for instruction-driven 3D modeling. 3DGPT positions LLMs as proficient problem solvers, dissecting the procedural 3D modeling tasks into accessible segments and appointing the apt agent for each task. 3DGPT integrates 3 core agents: the task dispatch agent, the conceptualization agent, and the modeling agent. They collaboratively achieve 2 objectives. First, it enhances concise initial scene descriptions, evolving them into detailed forms while dynamically adapting the text based on subsequent instructions. Second, it integrates procedural generation, extracting parameter values from enriched text to effortlessly interface with 3D software for asset creation. Our empirical investigations confirm that 3DGPT not only interprets and executes instructions, delivering reliable results, but also collaborates effectively with human designers. Furthermore, it seamlessly integrates with Blender, unlocking expanded manipulation possibilities. Our work highlights the potential of LLMs in 3D modeling, offering a basic framework for future advancements in scene generation and animation. Vision language models are zero-shot reward models for reinforcement learning. Reinforcement learning, RL, requires either manually specifying a reward function, which is often infeasible, or learning a reward model from a large amount of human feedback, which is often very expensive. We study a more sample-efficient alternative, using pre-trained vision language models, VLMs, as zero-shot reward models, RMs, to specify tasks via natural language. We propose a natural and general approach to using VLMs as reward models, which we call VLM-RMs. We use VLM-RMs based on CLIP to train a Mujoko humanoid to learn complex tasks without a manually specified reward function, such as kneeling, doing the splits, and sitting in a lotus position. For each of these tasks, we only provide a single sentence text prompt describing the desired task with minimal prompt engineering. We provide videos of the trained agents at the project's website. We can improve performance by providing a second baseline prompt and projecting out parts of the clip, embedding space irrelevant to distinguish between goal and baseline. Further, we find a strong scaling effect for VLM-RMs. Larger VLMs trained with more compute and data are better reward models. The failure modes of VLM-RMs we encountered are all related to known capability limitations of current VLMs, such as limited spatial reasoning ability or visually unrealistic environments that are far off distribution for the VLM. We find that VLM-RMs are remarkably robust as long as the VLM is large enough. This suggests that future VLMs will become more and more useful reward models for a wide range of RL applications. An emulator for fine-tuning large language models, using small language models. Widely used language models, LLMs, are typically built by scaling up a two-stage training pipeline, a pre-training stage that uses a very large, diverse dataset of text, and a fine-tuning, sometimes alignment stage, that uses targeted examples or other specifications of desired behaviors. While it has been hypothesized that knowledge and skills come from pre-training, and fine-tuning mostly filters this knowledge and skill set, this intuition has not been extensively tested. To aid in doing so, we introduce a novel technique for decoupling the knowledge and skills gained in these two stages, enabling a direct answer to the question, what would happen if we combined the knowledge learned by a large model during pre-training with the knowledge learned by a small model during fine-tuning, or vice versa? Using an RL-based framework derived from recent developments in learning from human preferences, we introduce emulated fine-tuning, EFT, a principled and practical method for sampling from a distribution that approximates or emulates the result of pre-training and fine-tuning at different scales. Our experiments with EFT show that scaling up fine-tuning tends to improve helpfulness, while scaling up pre-training tends to improve factuality. Beyond decoupling scale, we show that EFT enables test time adjustment of competing behavioral traits like helpfulness and harmlessness without additional training. Finally, a special case of emulated fine-tuning, which we call LM upscaling, avoids resource-intensive fine-tuning of large pre-trained models by ensembling them with small fine-tuned models, essentially emulating the result of fine-tuning the large pre-trained model. Upscaling consistently improves helpfulness and factuality of instruction following models in the Llama, Llama 2 and Falcon families, without additional hyperparameters or training. Enhancing high-resolution 3D generation through pixel-wise gradient clipping. High-resolution 3D object generation remains a challenging task, primarily due to the limited availability of comprehensive annotated training data. Recent advancements have aimed to overcome this constraint by harnessing image generative models, pre-trained on extensive curated web datasets, using knowledge transfer techniques like score distillation sampling, SDS. Efficiently addressing the requirements of high-resolution rendering often necessitates the adoption of latent representation-based models, such as the Latent Diffusion Model, LDM. In this framework, a significant challenge arises. To compute gradients for individual image pixels, it is necessary to backpropagate gradients from the designated latent space through the frozen components of the image model, such as the VAE encoder used within LDM. However, this gradient propagation pathway has never been optimized, remaining uncontrolled during training. we find that the unregulated gradients adversely affect the 3D model's capacity in acquiring texture-related information from the image generative model, leading to poor quality appearance synthesis. To address this overarching challenge, we propose an innovative operation termed Pixel-Wise Gradient Clipping, PGC, designed for seamless integration into existing 3D generative models, thereby enhancing their synthesis quality. Specifically, we control the magnitude of stochastic gradients by clipping the pixel-wise gradients efficiently, while preserving crucial texture-related gradient directions. Despite this simplicity and minimal extra cost, extensive experiments demonstrate the efficacy of our PGC in enhancing the performance of existing 3D generative models for high-resolution object rendering. An image is worth multiple words. Learning object-level concepts using multi-concept prompt learning. Textural inversion, a prompt learning method, learns a singular embedding for a new word to represent image style and appearance, allowing it to be integrated into natural language sentences to generate novel synthesized images. However, identifying and integrating multiple object-level concepts within one scene poses significant challenges even when embeddings for individual concepts are attainable. This is further confirmed by our empirical tests. To address this challenge, we introduce a framework for multi-concept prompt learning, MCPL, where multiple new words are simultaneously learned from a single sentence image pair. To enhance the accuracy of word-concept correlation, we propose 3 regularization techniques. Attention masking, ATTEN-mask, to concentrate learning on relevant areas, prompts, contrastive loss, prompt CL, to separate the embeddings of different concepts, and bind adjective, bind adjective, to associate new words with known words. We evaluate via image generation, editing, and attention visualization with diverse images. Extensive quantitative comparisons demonstrate that our method can learn more semantically disentangled concepts with enhanced word-concept correlation. Additionally, we introduce a novel dataset and evaluation protocol tailored for this new task of learning object-level concepts.